Alright, today we're talking about conic sections, two in particular, ellipses and hyperbolas. I'm going to kind of focus on the connection between the graphs of these and how they're very, very closely related to each other, and kind of looking at how to graph them, specific characteristics of each, and again, the connections between them. So, let's get started. You should have seen this before, hopefully in your class or on some sort of a worksheet or workbook, that the just standard form of an ellipse and a hyperbola. So some books have two different standard forms for an ellipse because they say that A has to be greater than B. I think that just adds complications to things, so I just keep A under the x term because in every other conic the A stays under the x term, and it's just easier with consistency there. But when I talk about foci in another video, I'll explain kind of how that adjusts things for you. It's a really simple adjustment. But what do these things mean? So H and K, as you see here, represent the center. So we have H always with the x term, which is why H is the x coordinate of the center, and then K is always with the y term, which is why K is the y coordinate of the center. And if you notice, just for some consistency here, we have A and B with an ellipse, we have A and B with hyperbola, and we have A and B with the other type of hyperbola. I'll explain the difference between these two later. But the box that's formed is always going to be 2A by 2B. So for example, if this were like 9 and 25, then A is 3, B is 5, and the box would be 6 by 10, or 2A by 2B. So again, we'll look at that in specific examples to make it more clear as we go. So let's first look at an ellipse and just see how this works. Okay, here we go. First example, we have the conic x squared over 4 plus y squared over 9 equals 1. And as I just said, this is an ellipse. But let's look at the big reason as to why we know this. So we know the possibilities are a circle, an ellipse, a hyperbola, and a parabola. Well, two of the terms are being squared, which means it can't be a parabola. And it's not a circle because my denominators are different here, right? So a circle would have the same denominator. So it's got to be an ellipse or hyperbola, hence the title of the lesson, Ellipse and Hyperbolas. Now the big difference between these two is this one has a plus symbol, and when it has a plus symbol, it's going to be an ellipse. If it had a minus symbol right here, then it would be a hyperbola, right? So that's the kind of the connection there to kind of piece that together. So oftentimes in a book or worksheet, they won't even tell you what type it is. You have to identify what type it is. So, do a little thought there. So we know it's an ellipse. The center, well, our standard form had x minus h relating to the center squared and y minus k relating to the center, right? But we don't have that here. We're not subtracting anything. Well, technically, we're just, when you're subtracting nothing, you're subtracting 0 from both of those terms. So my center here is going to be at 0, 0. If I was subtracting an actual number, x minus 2 squared, then my x value would be 2. So that's how that works. Now, when you are graphing it, the way we're going to do this here, the a squared, again, is under the x term here. A squared is 4. So we can just say, take the square root of both sides, a equals 2. Now what that means, in the x direction, again, a is directly related to the x value here. In the x direction, I'm going to count right 2 and left 2 and put 2 points there. And then in the y direction, well, since b squared is 9, take the square root of both sides, you get b equals 3. I'm going to count up 3, put a dot, down 3, put a dot, and now we have kind of some key components. I'm going to erase these middle lines here because usually we don't have these written there. I was just showing you that I know how to count. Well, two of these are going to be called vertices. Two of them are called covertices. So the ones that are further away, so this is a length of 3 and a length of 3, and this is a length of 2 and a length of 2. So obviously the 3, this segment there, is the longer of the segments, so that's called the major axis, right? And the endpoints of the major axis are both vertices. So the vertices are at 0, 3 and 0, negative 3. And then the minor axis, which connects these other 2 points, the smaller of those 2 axes, those are called covertices. And then all we simply do is connect the dots, beautifully, wonderfully made, etc., etc. Now, here's what I've seen a lot of students do, just to kind of connect this to hyperbolas, which I'll show you more of in a second. A lot of students like to, when they count up 3, down 3, left 2, right 2, they like to make the box even with an ellipse, right? So they put the box around here, and it goes through the vertices, through the covertices, because then they get just so used to that process, and that box, if drawn properly, which my ellipse is sloppy, but when drawn properly, it circumscribes the ellipse, right? The ellipse is inscribed inside that box. So they just get used to that habit because you do the same box for ellipses and hyperbolas, which I'll show you in a second again. So I've seen some students do it, some students don't. I don't really care which one. Whatever helps you do it better. Here we go. Let's look at a hyperbola. This graph is very closely connected to the other one. The only difference is that the other one had plus, this one had minus, which that one small change changes this to a hyperbola. The center, as I've already explained, is at 0, 0. The box, up 3, down 3, right 2, left 2, connect the dots. We've got a box. Wonderful, wonderful, wonderful. Okay, now, again, if this were a plus sign here, then you would just connect these and then ta-da, you're done. Since it's a minus, we have to add a step here, and that's going to be looking directly at this concept of asymptotes. So the hyperbola, you're supposed to draw asymptotes along the diagonal, assuming I actually know how to connect the dots here, along the diagonal, there we go, and it goes directly through the center. We're going to do the same thing on the other side, along the diagonal, going through the center, etc. Now, if I asked you for the equation of those asymptotes, well, those are just lines, right? So we're looking for some linear equations. Well, there's 3 forms. There's standard form. Who wants to use that? Nobody. There's slope-intercept form, which is what you've been learning for a very long time now. And then there's point-slope form, which a lot of students don't like to use because they forget what it is. But it's the easiest to use because all you need is the slope and a point on that line. Well, the slope is just rise over run, right? We're looking at, it's going up 3 over 2 to get from the center to that, like the vertice, the vertex of that box. Up 3, right 2. Some students like to count the entire dimensions. Well, this is up 2b, right? It's up 6, right 4, which just simplifies to the same thing of 3 over 2. So my slope is 3 over 2. And a point, always use the center here. Because again, all of these have to go through the center. So if you're always using the center, it's built into the problem for you. I know that this point is going to be 0, 0. So I'm going to then, why is this not working? I'm going to then create my equation. So it's going to be y minus 0, right? The whole y minus y1 equals m times x minus x1, barely fitting on there. So that's the equation of a line and point slope form. So y minus 0 equals 3 over 2 times x minus 0, which just simplifies as y equals 3 over 2x once you distribute it through. Right? So that's the equation of one of the lines. Well, the other line is just simply the same point. It goes through the center, and the slope now, instead of being positive 3 over 2, is just negative 3 over 2. So we have one positive of 3 over 2, one negative, so I end up with 2 lines. One of them has the equation y equals positive 3 over 2x. 1 has the equation y equals negative 3 over 2x. And then we go from there. So, I should actually graph it, shouldn't we? That's a good idea. Well, it's either going to be here on the up and down going vertically, or it's going to be here going horizontally. Again, hopefully I draw it better than I just did. But how do we know which one of those it is? Well, it all depends on whichever term here is positive. Okay, so since the x term is positive, that means it's going along the x-axis, which means it's a horizontal hyperbola. So we're going to start, my vertices end up being on the minor axis here of that box, and I am connecting, I'm again not touching the asymptotes, because an asymptote is just going to get really close to that. It's just going to go along very closely. Okay, it's going to get uncomfortably close to the asymptote. And now I have my hyperbola. Well, what happens here? Y squared over 9 minus x squared over 4 equals 1. Again, this should remind you of the last couple problems that we've done. It's still a hyperbola. Let's put this back in black here. It's still a hyperbola. So I'll just put h for hyperbola. Again, we know that because of the minus sign there. The center is still 0, 0. The asymptotes are still going up 3 over 2, up 3 over 2, so one of them is going to be y equals positive 3 over 2x, and one of them is going to be y equals negative 3 over 2x. So it's the same initial graph that I had before. I'm just going to quickly sketch this here. So here's my box. Fun, fun, fun. Here's my asymptotes. Oh, so terribly drawn. Here's my asymptotes. And then the only difference, though, is that now the y term is positive, which means I'm going to be graphing vertically as opposed to horizontally. So I'm going to be starting here now are my vertices, and I'm graphing up on top. So instead of the other one was graphing left and right, this one is graphing up and down simply because the y term is positive. Okay. I'm going to stop it here. The next example I'll just show you is looking at what happens when it's not centered at 0, 0, which has even an effect on the asymptotes. It's not just shifting. So I'll show you that in the next part. Hopefully it won't be too long. But yeah, check back part number 2 just a minute.